Hey everyone, welcome back to Future PC. Now we've all heard about the best GPUs for deep learning, like NVIDIA's RTX 4090 or A100, but what about the worst? Today, I'm going to break down some GPUs that just don't cut it when it comes to handling AI workloads. Whether you're training neural networks, running large data sets, or experimenting with generative models like Stable Diffusion, these GPUs will leave you frustrated, waiting hours or even days for results. Let's quickly cover why certain GPUs perform poorly for AI/ML tasks. The main factors include lack of CUDA cores or tensor cores. These are essential for parallel processing and accelerating AI computations. Insufficient VRAM. Training models often requires 8 GB, 16 GB or more of memory. Anything less is a non-starter. Old architecture. Older GPUs lack optimizations for modern frameworks like TensorFlow and PyTorch. With that said, let's get into the list. First up, we have budget gaming GPUs. Think cards like the NVIDIA GTX 1050 Ti or AMD RX 550. While they might handle basic games at 1080p, they fall flat for AI tasks. For example, the GTX 1050 Ti only has 768 CUDA cores and 4 GB of GDDR5 memory. That's barely enough to load most modern AI frameworks, let alone train anything meaningful. And forget about multitasking. If you try to run another app while training, your system will likely crash. Oh, and good luck if you want to experiment with something like ChatGPT fine-tuning. It'll take weeks. Next on the list, integrated graphics. Yes, I'm looking at you, Intel UHD graphics and AMD Vega GPUs. These chips are designed for lightweight computing, not heavy-duty number crunching. They share resources with your CPU, which means limited bandwidth and no dedicated VRAM. Trying to run AI models on integrated graphics is like asking a bicycle to win a Formula One race. It's just not happening. I mean, sure, you could technically install TensorFlow on this, but why would you put yourself through that torture? Now, here's where things get tricky. Some entry-level modern GPUs may seem okay at first glance, but they still fail miserably for AI because they lack tensor cores. Take the NVIDIA GTX 1650 Super, for instance. It has decent specs for gaming, but without tensor cores, it can't leverage technologies like NVIDIA's DLSS or mixed precision training. And then there's the AMD RX 6400. Don't get me wrong, it's great for casual gaming, but its lack of software support for AI frameworks makes it nearly useless for ML projects. If you're serious about AI, avoid anything below the RTX 30 series from NVIDIA or the RX 6000 series from AMD. Segment 4, high-end gaming GPUs without enough VRAM. Here's a curveball. Some high-end gaming GPUs also make this list, not because they're bad overall, but because they lack sufficient VRAM for serious AI work. For example, the RTX 3060 12 GB is fantastic for gaming, but once you start working with massive datasets or complex models, those 12 GB won't be enough. Same goes for the RX 6700 XT. Sure, it has 12 GB of GDDR6 RAM, but AMD's ROCm platform still lags behind NVIDIA's CUDA ecosystem for AI development. You'll spend more time troubleshooting drivers than actually training models. Finally, let's talk about aging flagships. Cards like the GTX 980 Ti or R9 Fury X were beasts in their day, but technology moves fast. Their outdated architectures simply can't keep up with today's demanding AI frameworks. Plus, finding compatible libraries and drivers for these older GPUs is a nightmare. Even if you manage to set everything up, the performance will feel like watching paint dry compared to modern options. So now that we've covered the worst offenders, what should you look for instead? Here are my top picks. For enthusiasts, the RTX 4090 or RTX 3090. Both offer incredible performance and tons of VRAM. For budget-conscious builders, the RTX 3060 Ti or RTX 4060 Ti are solid starting points. And for professionals, consider NVIDIA's A100 or H100, though they come with a hefty price tag. Remember, investing in the right hardware saves you time and frustration in the long run. So unless you enjoy staring at progress bars all day, steer clear of the GPUs we talked about today. That's it for this video. If you found this helpful, give it a thumbs up and subscribe for more tech tips. Let me know in the comments which GPU you're using for AI. I'd love to hear your experiences. Thanks for watching, and I'll see you in the next one. Thanks for watching. Don't forget to like, share, and subscribe.